Hi, Assalamualaikum. Welcome back to my channel, Physics for 5 SSM. Today we continue 3.4 Electrical Energy and Power. In this video, I will discuss three learning standards. The first one, solve problems involving electrical energy and power in daily life. The second one, compare power and rate of energy consumptions in various electrical appliances. And the third one, suggests ways to save usage of electrical energy in household. Okay, the first part that I want to discuss is about relationship between electrical energy E, voltage V, current I, and time T. Electrical appliances convert electrical energy into other forms of energy. For example, lamps produce light and heat energy when supplied with electrical energy. As you can see here, electrical appliances like thermoflask here use heating element to convert electrical energy to heat energy that can boil water. Same case with this oven. Convert electrical energy to heat energy that can cook food. Or the sewing machine here convert electrical energy to mechanical energy. So based on the formula of potential difference, V equals to E divided by Q. If you still remember, we have discussed this formula under the topic of potential difference, where V is potential difference, E is electrical energy, Q is amount of charge flowing. Thus, we get electrical energy E equals to VQ. If we substitute the formula of Q equals to IT, we get the relationship between E, V, I, and T can be formulated as E equals to VIT. The SI unit for electrical energy E is joule. So this is the SI unit that we always use for energy. Okay, the second part we want to discuss on power. The relationship between power P, voltage V, and current I. Normally, when you buy an electrical appliances, we always check the level. You can see there is a voltage stated there. For example, here 220 volt, and the power of the electrical appliances 800 watt for this example. Okay, so the value of voltage and the power stated at the level here is known as power rating. This is one more example. So you can see there's a voltage 240 volt and power 1200 watt. The level of power rating actually displays the voltage and electrical power required to operate the electrical appliance. Means the electrical appliance will function at normal function when connected to voltage of 240 volt of power supply, and it will consume 1200 joule of energy in 1 second. So let's have one example. Let's say an electric rice cooker with power rating of 240 volt and 700 watt. What does the power rating of the electric rice cooker means? It means that the electric rice cooker will use 700 joule of electrical energy in 1 second when a voltage of 240 volt is supplied. That's the meaning of power rating. So let's look at a formula for power. From the formula of power, we know that power is a rate of energy transferred or rate of work done. For an electrical appliance, we can determine electrical power equals to electrical energy used divided by time taken. Electrical energy normally denoted as E. Thus, we get the power P equals to E divided by T. And from the first part just now, we have discussed electrical energy E equals to VIT. Therefore, relationship between P, V, and I can be derived as, we just substitute the formula of E equals to VIT into the formula of power. Thus, we get P equals to VIT divided by T. So we can cancel the T. So we get power P equals to VI. From Ohm's law, B equals to IR. Two other equations for electrical power P can be obtained as follows. For example, we use the formula of Ohm's law. Just now, we have derived that P equals to VI. Now we substitute current I. From this Ohm's law, I equals to V divided by R. Thus, we substitute here V divided by R. Then we produce one more formula for power. P equals to V squared divided by R. From the same formula, P equals to VI, using the same Ohm's law, V equals to IR, substitute the value of V. So V equals to IR here. So we get the formula P equals to I squared R. So from here we have how many formula already? This is the first formula. This is the second formula. This is the third formula. And this is the fourth formula. So it means the formula of power can be derived just by substitution of Ohm's law equation, V equals to IR. So from this one, we get SI unit for electrical power is watt or joule per second. Joule second to the power -1. So this is a summarize for the formula just now. If you play with the formula to produce other formula, for example, power watt, it can determine by using this formula, V squared divided by R, I times V, R times I squared. That one we already discussed just now. If you want to determine for volt or voltage, so V equals to IR, which is known as Ohm's law. V also equals to P divided by I, or V equals to square root of P times R. From here, we can derive the formula by just arrange the formula to make V as a title for the formula. So we get V equals to square root of P times R. For resistance R, from Ohm's law, R is equals to V divided by I. R equals to P divided by I squared, and R also equals to V squared divided by P. So you can look at here how we get the formula. And then for current I equals to V divided by R from this equation or this formula. And then I equals to P divided by V, and I equals to square root of P divided by R. So all these actually you can get by derivation. So let's look at some example. Example 1, figure 3.35 shows a circuit that is supplied with a 6-volt battery to light up a lamp. If the current is 0.7 ampere, what is the amount of electrical energy used to light up the lamp for 1 minute? Okay, first of all, if you look at the circuit here, we have a bulb connected to 6 volt of power supply or battery. List out all the information given. Potential difference V equals to 6 volt. Current I equals to 0.7 ampere. Time taken 1 minute, you need to convert to second, equals to 60 seconds. Electrical energy used to light up the lamp for 1 minute, E equals to VIT. Substitute the value of V, I, and T. So we get 6 times 0.7 times 60. So we get 252 joule. So this is the amount of electrical energy used to light up the lamp for 1 minute. Second example, a fluorescent lamp is labeled 240 volt and 32 watt. Calculate lamp resistance, current flowing through the lamp under normal conditions, electrical energy that is supplied for 3 hours in kilojoule. Let's look at the first part A, the lamp resistance. The information given from the power rating, we can get the value of V, 240 volt, the power P, 32 watt. Thus, we can calculate resistance R equals to V squared divided by P, thus equals to 240 squared divided by 32 equals to 1800 ohm. So this is resistance of the lamp. Now we want to calculate the current. From the formula of I equals to P divided by V, power 32 divided by V 240, so we get 0.13 ampere. Electrical energy supplied for 3 hours in kilojoule, so the formula is E equals to PT. Power 32, the time taken 3 hours need to convert to second. Because we are using SI unit here, the final unit is joule, which is SI unit. So we get 10,800 seconds. So substitute the formula into the formula. So we get 345,600 joule. Convert to kilojoule, because here stated need to state in kilojoule. So what you do, you just divide by 1000 or divide by 10 to the power 3. Thus we get 345.6 kilojoule. The power and energy consumption rate for various electrical devices. As you know that different electrical appliances sometimes have different power rating. So based on the power rating or the label, you must be able to choose which one is more efficient to be used. Okay, nowadays a variety of electrical appliances are available in the market. Consumers need to be wise in choosing electrical appliances that provide maximum energy saving. So we always talk about energy saving. At the same time, we can save money. For example, a 40-watt compact fluorescent lamp or CFL and a 12-watt light-emitting diode LED both produce the same brightness. But look at the power. Different in power. If they are switched on for 12 hours a day, compare the cost of energy consumption for both lamps for 30 days. So which one is more efficient? Let's try to calculate the cost of energy consumption for both of the lamps. So let's look at the comparison of cost of energy consumption between CFL and LED. For CFL, the power just now is 40 watt. Energy use, we use the formula E equals to PT. First of all, we need to calculate number of unit used by CFL. The 1 unit of electricity is equals to 1 kilowatt hour. The calculation of electric bill based on the electrical tariff need you to calculate number of units used or how many kilowatt hour of electrical energy consumed. So for this one CFL, P equals to 40 watt, you need to convert to kilowatt, meaning 40 divided by 1000. The time taken or time of usage must be in hour. That's why we get the unit kilowatt hour. If time given in minute, you need to convert to hour. Or time given in days, you also need to convert to hour. So for this CFL, we get 0.48 units or 0.48 kilowatt hour. Given that the cost of energy consumption is 0.218 per unit, this is the electrical tariff. Means Ringgit Malaysia 0.218 per unit. So cost of energy consumption for 30 days, if this amount of unit is consumed for 1 day, so if for 30 days you need to multiply by 30. So 30 times 0.48 times electrical tariff. Ringgit Malaysia 0.218. So we get RM 3.139. So this is the cost of energy consumption for CFL. Let's look at LED. The power of this LED lamp is 12 watt. So E equals to PT. Convert the 12 watt to kilowatt, so we get 0.012 multiply 12 hour. Thus we get 0.144 units or 0.144 kilowatt hour. The cost of energy consumption is 0.218 per unit. Thus the cost of energy consumption for 30 days, 30 days times 0.144 times RM 0.218, so we get RM 0.942. Now you can compare the cost of energy consumption. As mentioned earlier, both type of lamps produce same brightness of light. Thus, we can conclude that the energy consumption of LED is lower than CFL. So this shows that LED has a higher efficiency and is more energy saving compared to CFL. You also can save your bill. Let's look at activity 3.10. Aim to calculate electrical energy consumption at home. So this one will become one of the project-based learning. Carry out this activity individually. Scan the QR code and print table 3.16. List all the electrical appliances that are found in your home, such as electric rice cooker, television, lamp, electric oven, fan, aircon, and so on in the table. Collect information on the consumption of electrical energy based on the power rating of the electrical appliances. For each electrical appliances, determine the quantity, power, and hours used in a day. Estimate the cost of electrical energy consumption for a month. For example, you get ready with this table and then list down all electrical appliances that can be found in your home, and then you calculate the total energy usage for each of the electrical appliances, then calculate cost of electricity consumption in your home. So present the results of your findings. Okay. Steps in reducing household electrical energy usage. These are some of the suggestions. Maybe you have other idea about the steps to reduce electrical energy usage. For example, close all windows and doors when using aircon, and ensure that the aircon filter is kept clean to cool the room down faster and more efficiently. Okay. Switch off electrical appliances when they are not in use to conserve energy. Use only full loads of laundry when using washing machine. Use energy saving lamps to reduce energy consumption. So you can, if you have other idea, okay, so you can just add in your idea as a step in reducing electrical energy usage and also to reduce cost of energy consumption. Okay, let's discuss formative practice 3.4. Number 1, the output power of battery is 80 watt. Determine electrical energy that is supplied by the battery in 10 seconds in 2 hours. Look at part A. Power 80 watt times 10 hours. Electrical energy E equals to PT. P in watt, T in second, thus we get 800 joule. For 2 hours, you need to convert time taken 2 hours to second. Thus, electrical energy E equals to 80 watt multiply 7,200 second. Okay, you can write your answer in joule or kilojoule. So 576 kilojoule. Number 2, if the cost of electricity is 30 cents per unit, calculate cost of using 600 watt LED television for 8 hours, 1 kilowatt vacuum cleaner for half an hour. A. Power P equals 600 watt. Time T equals to 8 hour. Energy use 0.6 kilowatt times 8 hour. So we get 4.8 kilowatt hour. So look at the value of P given, watt. So you need to convert to kilowatt. Time taken is already hour. So the number of unit is 4.8 kilowatt hour or 4.8 unit of electrical energy consumed. The unit cost equals to Rm 0.30. So cost of energy use equals to 4.8 times 0.30. So we get Rm 1.44 ringgit. Okay. So this one is for the LED television. Let's look at for the vacuum cleaner. Power P 1 kilowatt times 0.5 hour. Energy use in kilowatt hour is 1 kilowatt times 0.5 hour. So we get 0.5 kilowatt hour or 0.5 unit. Unit cost is 30 cents or Rm 0.30. Cost of energy use 0.5 times 0.30. Thus we get Rm 0.15 or 15 cents. Okay. So that's all for this topic, electrical energy and power. So you can try more example on this using the formula of electrical energy and power. So that's all for today. Thank you for watching. Bye.